This evening's presenter is Joe Miranda. Joe is the designer of over 400 board-based war games. He has also been on the design team for several computer games to include companies such as HPS Simulations, LECMgt, and Hexagon Interactive. Joseph is a veteran of the U.S. Army, as well as having been an adjunct professor in criminal justice. He has developed university courses and seminars on various aspects of modern warfare to include terrorism, counteraction, and counterinsurgency. He has also been the author of several hundred articles on military history, law enforcement, and modern conflict. And tonight he'll be discussing wargaming and cyber warfare. And with that, Joe, feel free to take it away.
Good. I'm ready to roll. Good evening. I'm doing this from the offices of Dr. Roger Mason, so that's why it says Roger. My name actually is Joseph. Let's just remember that. All right. We have a lot to cover this evening. I'm going to go look at the background to cyber war and deal with some of the aspects of designing cyber war games, and then some of the downsides and where all this stuff may be going. The picture that you're seeing now of the fellow standing up there with all the cyber gear, I took that about 20 years ago. This is a fellow who used to wander around downtown Los Angeles, and he was supposedly going to be the wave of cyber future, and he's kind of ahead of his time. So that is not me. All right. Roger, the slides, wait a second. The slides aren't actually working. Hold on a second here. How do we get to the next one? Did you hit enter? I hit enter. There we go. All right. I just had to hit the key a little harder. All right. How do I get involved in cyber wargaming? Well, let's go back to 1991. And these are pretty heady days. The Berlin Wall had fallen. Communism seemed to have come to an end. Operation Desert Storm. U.S. coalition victory in the Persian Gulf against the Iraqis. At this time, new fields of warfare were starting to emerge. It was called the Revolution in Military Affairs, a combination of precision-guided weapons, advanced targeting systems, and new doctrines seemed to be sweeping the field. Well, a couple of years later, I was driving down to Montgomery, Alabama with Kirk Schlesinger. He was one of our game developers. And we were discussing what we were going to talk about. And I said, well, let's talk about insurgency. And he said, yeah, okay, but we're going to talk about the same old Cold War era insurgency stuff, you know, guerrilla warfare and propaganda. And he said, here's a better idea. Since all these new technologies are coming online, why don't we look at how they're going to affect us? And why don't we look at how this is going to affect this newfangled thing called the internet, okay? And at this time, we were using Genie. This was the General Electric Network for Information Exchange to coordinate different people in different parts of the country to do war game design, okay? And you could basically exchange information via a text screen. And it was actually did a lot because I lived in California at the time, and Kirk was out in Ohio, and there are people all over the country we were working with. So this was kind of the brand new thing, and we were looking at some of the policies that were in place and how these could be used in modern warfare. Well, he came up with an idea called data conflict. The idea being that you could use the internet to somehow, some way, conduct modern operations. Okay. So the result is I designed a game called Cyber Crisis 2000. This was done for GameFix magazine. Okay, and it posited a breakup of the United States and a civil war, and you had two players, one representing the government and one representing the insurgents. The critical thing was that conflict was conducted not only in the sphere of conventional military operations, but by a data conflict. In other words, what we would call today information operations and cyber war. It's just that those terms had not come into general use at the time. And the map shows the country divided up into different regions according to their, basically their population densities. So you have urban areas, and you have wilderness areas, and you have areas in between. And there's a reason for doing it this way. Okay, So this is your order of battle. These are basically standard war game units. You punch them out and put them on the map. Okay. And if you'll notice, each unit has the three numbers along the bottom. The first is its data conflict. The second is its conventional combat. And the third is its movement factor. And so this is a way to quantify all the different types of conflict that you're going to come into use with. Now, here is the critical thing. If you look at the counters on the bottom, the yellow counters, these are your cyber war campaign markers. The way you use them is that they actually provide modifiers to your combat strength. There's three numbers, and they correspond to the three different types of terrain. So, for example, if you look on the top yellow row, the second yellow counter, it says mass rally. Well, it has three numbers. The first one, the 4, is its use in urban terrain. The second is in intermediate terrain, and the third is its use in wilderness terrain. So in other words, this would be useful if you call it a mass rally in an urban area, not so much if you're out in the Grand Canyon. And you can see there's several other types of markers there, depending on various things that were, that were in the media at the time. For example, you have a virtual reality counter in the lower right, and then some of the markers have a star, and these are special markers, and you have to look up the rules, and they'll tell you what you can do. This is a way to quantify all these various non-material, cybernetic, and other technological factors that were not out there on the battlefield. And as for the counters, you can flip them over, and if you convert them to your side, they turn a different color. Okay, so this is a way to present a cyber conflict overlaid onto a conventional war. All right. All right. As for counters, normally when I do something that has cybernetic units in it, cybernetic factors, I usually use cards. Because cards are a lot easier to use. Now, this is from a completely different game. This is from a game I did on the Battle of Khe Sanh back in Vietnam. But cards really work well. Why? Because people like to play with cards. One thing I have found is that when it comes to gamers, they don't want to read rules books, but if you give them a set of cards, they'll poke through them and they'll read them, they'll memorize them, and they'll start strategizing how to use them. So cards are always a good thing to have in a game. In this case, just very briefly, Operation Prairie Fire lets you go into Laos and do certain things against communist lines of communications. The Dow Tran card, that's used by the communists to give them additional morale. So again, it's a way to get both material and non-material factors into the game. All right, so let's go back a bit. Let's go back to the early 19th century. Charles Babbage designs something called the differential engine. He follows it up with the analytical engine. The differential engine is essentially a very complex adding machine. The analytical engine is a little more closer to what would be considered a modern computer system. It's all mechanical, it all uses gears, and basically it has a central processing unit, which he calls the mill, and it actually could store information up to a whole kilobyte using different gears, and it actually had a printer attached to it. Now, this is a mock-up. He actually built something of his first one, the differential engine. But when it came to the analytical engine, he could only get it as far as the plans. There have been various attempts to build a working model since then. So we shall see if this perhaps is the future of wargaming. All right. And that's Charles Babbage on the right, and that's Ada Lovelace, who he worked with, and she publicized this. And so they go down as the first two real cyber guys, cyber gals. Okay. And this was what they used to input information. These are punch cards. They were used originally with mechanical looms to create patterns on fabrics. Okay, so this is the origin of the punch card. And it's a way to store information and import part information. All right, let's go a little further into the 19th century. You have George Sorel and the myth of the general strike. George Sorel starts off as a left-wing radical. He ends his life as a right-wing radical. Sorel's point was that modern society, in other words, 19th century society, was based on the Industrial Revolution. That whoever controlled the means of production, the factories, would control society. Why? because that's where the workers were, that's where the wealth was, that's where the productivity was. The cities were now becoming the center of gravity, okay? And his whole contribution was this idea was that whoever controlled the factories would control society. And his idea was that one day the workers would all walk off and then they'd all walk back on, and then suddenly they would be in control. And again, he really starts this off as a left-wing idea. Later on, it becomes a big right-wing idea with people like Mussolini and others. But they all grasped one thing, and that was the factories had become the center of gravity for any modern society, especially from the military end, because of course, if you had factories, you could produce weapons and ammunition and supplies. These are the Skoda works in what is now the Czech Republic. At the time, it was part of the Austro-Hungarian Empire. This was one of the industrial centers of Europe. You control the Skoda works, guess what? You can roll out those cannon that you always needed. Okay. In fact, in 1939, one of the reasons why Hitler takes over Czechoslovakia is because he gets the Skoda works. And what's that? The Skoda works producing? Well, tanks and trucks and airplanes and all the other stuff you need to have fun and games. All right. Well, back then, the idea of a revolution is you'd storm the Winter Palace, you gain control. It was very physical, very real. You had to actually control physical infrastructure. Okay. World War II, infrastructure warfare. This is the Ploesti bombing raid of 1943. The Allies bombed the Ploesti oil fields and refineries in Ploesti, Romania. The idea being, okay, if you knock out Axis petroleum production, you undermine their entire war economy. Okay, but there are other ways to attack. There was electronic warfare. Okay, and you had psychological operations, in other words, propaganda. So what's happening is warfare is expanding beyond simply fighting other people physically. It's going into the realm of electronics. It's going into the realm of what would consider to be today information warfare. All right, well, you have computers now being produced. The differential analyzer is essentially an analog device which can store information, perform complex calculations, and provide output. The Colossus computer was built during World War II. This was used by the British to break German codes. I should note this was not used as part of the Enigma program, the Enigma breaking program. This was for other German codes, but it's essentially a computer, and it can process all sorts of information, provide outputs, perform calculations, and do all the other things that we recognize as being computers, which you can do now with your device on your wrist, okay? And this was a typical computer of the 1950s. One of the things to understand is that these computers are all one-of-a-kind things. People would build one, but there was no idea that you were going to actually mass produce them. In fact, people thought mass producing computers wasn't much of an idea. And also, there was no way to link them. So if you had information on one computer, you could not be linked to the others. And this was an input device in the 1960s. Okay, it's a punch card. Possibly you have seen one of these in a museum. When I was an undergrad back in the late 1970s, it was considered to be a mark of honor to be in the engineering department and walk around with a bunch of punch cards in your pocket. So a bit of history there. And other means of storing included magnetic tape. Again, if you ever see old movies or computers running with these tape decks, well, that's how they stored the information on a magnetic tape. Okay. Well, let's look at the sort of the popular interpretations. Gene Roddenberry brings Star Trek to the television screen in the 1960s. And one of his ideas is we're going to show people what computers can do. And apparently what you do with the computer is that you talk at it and it gives you information. And if the computer is giving you problems, you find some way to put it in an infinite feedback loop, which will crash the computer, which is sound advice for today, by the way. So they were ahead of their time. Note, though, they had no keyboards, and so they couldn't quite play video games on them. All right. 1966, Robert Heinlein publishes The Moon is a Harsh Mistress. All right, this is interesting because this is one of the first depictions of a cyber war. And the premise is that rebels on the moon are fighting against the Earth government. And the way they do it is they have this super intelligent computer that is actually self-aware, and that gives them all sorts of advantages. So what they can do is sabotage the enemy's systems, and the enemy isn't quite aware of it. One of the things it deals with is human-machine interfaces. The lead character in it, who's you can see on the cover, has a mechanical left arm. And so there's this idea that you can replace parts of your bodies with cybernetic implants. And the computer itself develops a personality and becomes like a living human being. Again, ideas that were pretty much ahead of its time. And so Heinlein can go down as sort of a pioneer in this. It's worth reading it, although one caveat I'd have about the book is that Heinlein seems to assume that only the rebels have this idea of using the computer and that the Earth government can't quite figure it out. And it was giving them a little too much author input there, but okay. Another thing to look at, 1967, James Coburn stars in The President's Analyst. It's a spoof about spy movies, but not quite, because it has a very serious undertone to it. The backstory is that there is a secret organization whose name I won't give you, which is planning to implant transistorized communications devices in everybody's brains. And this way, everybody can talk to everybody else in the world only by thinking. Okay, so this way you can get rid of all the telecommunications infrastructure. And also the movie goes on the premise that there's universal surveillance being conducted covertly. It's well worth checking this movie out because, again, it's a movie that was way ahead of its time, and it had a lot of interesting ideas, which at the time were considered to be totally insane, but today are, you know, you're seeing them play out, okay? 1968, 2001, A Space Odyssey, Stanley Kubrick's movie about basically an expedition to Jupiter and then into hyperspace beyond it. One of the elements of the movie is that the ship is run by a supercomputer which gains self-awareness and then proceeds to try and kill the astronauts aboard. And so in this scene, one of the astronauts is deactivating the computer. And another movie worth watching. All right, 1972, the game Pong comes out, probably the first real computer game. That's what they used to play back in those days. And yes, people did dress like that. All right, meantime, the Advanced Research Projects Administration, which is today called DARPA, is providing grants to create what becomes known as the ARPANET. The idea behind ARPANET is to connect all the research computers into one system so people can share information. Now, there's some theory also this was created to provide an alternative communications network in case some of the critical cities that had the communication centers were destroyed by nuclear attack. There's some debate of whether or not it's really true or not, and some people claim it is and some not, but who cares? But this becomes the foundation of what is today the internet. The idea is that instead of having a centralized communication system, it becomes distributed. Every computer can talk to every other computer, so guess what? It's impossible to knock out the entire system with a single attack on a single target or even group of targets. So, all right, 1982, you have the movie Blade Runner, and this shows, I think, a shift in science fiction and the depiction of the future, which has wider social implications. Instead of the older systems of ray guns and rocket ships, what you have is a future that's built around genetic engineering and sort of routine use of computers. You see at one point, the Harrison Ford character uses a computer to enhance a photograph to provide clues. Again, something that was sort of ahead of its time. Okay. And you had William Gibson, who was one of many what became known as cyberpunk writers. And they posited a future in which amoral hackers break into systems to redistribute wealth in their own direction, or to conduct sabotage, or conduct various types of cyber war. And the assumption here is there's a worldwide network of these computer systems, and that anybody can gain entry with the right software, sometimes hardware. And also that within the internet, there's actual 3D visual objects, and that you essentially, you jack in, you plug in, and you can visualize these, and these are the objects that you will manipulate. This is important because I'll share later on one of the games I did use this concept. Okay, 1990, Steve Jackson Games publishes Cyberpunk. It's a role-playing game based in a cyberpunk universe where essentially you're trying to do hacks and you're trying to survive in this sort of slightly dystopian universe. It says the book that was seized by the U.S. Secret Service. The story is that the Secret Service thought this was a handbook on how to do cybercrime. Well, it wasn't. The only thing you can really learn from it is how to roll dice against your character's characteristics, and that's not very useful in real-world hacking. However, I highly recommend reading it because it does show you where a lot of stuff was going, and it's actually a fun read. All right, 1998, Will Smith stars in a movie called Enemy of the State. The premise is that he's a lawyer, and suddenly he finds himself losing his credit cards and his phone and everything, and it's like, it turns out that some agency above him is trying to delete him from the system. Unfortunately, it does have a happy ending because Gene Hackman comes in playing essentially the same character he played in another movie dealing with surveillance called The Conversation, and saves the day. But again, it's worth watching to see where things were going. Finally, 1999, you have The Matrix. The Matrix really was like a major turning point because now it said that people would be living within an artificial reality, and that they would be interacting, and that would become the reality, whereas their real lives are being lived kind of either inside of pods or living as underground outlaws. And this really had a nice depiction of virtual reality to the point where it becomes the reality. And as we'll be seeing, this is a concept I'll be using later on. The term is going to be called hyperreality. All right. Well, the Department of Defense is getting in on this all too. This was published back in the 1990s, Networks and Net Wars, by the RAND Corporation, which is the big think tank. And it's a description of how all these emerging technologies were affecting insurgency, were affecting crime, were affecting law enforcement, were affecting counterintelligence. In fact, when I was teaching a class on criminology, I had people read this to say, well, this is where we're going, so maybe we ought to all take a look at it. So Networks and Net Wars. Okay. Well, everything is increasingly becoming networked. Everything is connected to everything else. And if you have computer controls for your infrastructure, whether it's information or utilities or transportation, it's a vulnerability. Why? Because people can hack in and they can gain information, they can sabotage you, they can manipulate data. So suddenly, even though you're making things much more efficient, you're creating a huge vulnerability. And the other critical thing is that as increasingly more things are networked, it's more easy to disseminate things like viruses, and it's more easy for everyone to communicate with everyone else and coordinate better. So it becomes like a race of between black hats and white hats and whatever. All right, September 11th, 2001. You have the beginning of the global war on terror. And cyber war is global. Everyone can attack everybody else in the world, and you can do it from the comfort of your own basement. For example, you have cyber command control. Well, now, because military units are linked with other military units worldwide by satellite or other means, that you can now control operations globally and just as critically get information globally. Okay, so if you have an infantry guy out there in the front line, he can send information back to the Pentagon or wherever, some central command control facility. And what they can do then is target anything up front. So you've got this huge flow of information. It means jumping normal chains of command, but again, it means more vulnerabilities. All right, you have cyber intelligence. Okay, if you can hack into the enemy systems, you can figure out what he's doing. You can download his files. You can distort his files. So again, the internet becomes a front for intelligence operations. All right, you have psychological operations. People can now use the internet to win people over to their side, to conduct disinformation, to coordinate various different parts of their network. So again, the internet now becomes a front for psychological warfare or propaganda and information operations. And cybercrime, you can now hack into other people's computers, download their financial information, transfer funds, sabotage them. Well, I'm sure we all know what all the different things you can do is you can hold people's computers hostages, you can use zombie computers. So again, this becomes a major front. Okay, and then you have infrastructure, and again, you conduct infrastructure attacks. So in other words, now your infrastructure is all vulnerable. Okay, you can also train people. Okay, so this is a virtual reality simulation, but you can now train people worldwide. If you're dealing with a global level insurgency group, you can now tell your people what you want them to do. You can show them how to use weapons, how to employ PSYOP, whatever. So you don't have to gather everybody together in a barracks or training field. You can do this globally. You can distribute it. And you can even do your logistics. Supposedly, this is an assault rifle that was built from 3D printing, and it was based on plans downloaded off the internet. I said supposedly, that's just what the story said, but probably true. Okay, so you end up with the cyber battlefield. And this has three components. You have a sensor grid, you have a command control grid, and the shooter grid. They all work together to coordinate operations worldwide. Much of this gets back to that revolution in military affairs. Okay, you have precision guided weapons, which can be called in on targets, which have been determined by your sensor grid, which in turn has been coordinated by the command control grid. And finally, countries start organizing for cyber warfare. US has a cyber command, it's a 4-star command. Every other major power has one too, where they employ various cyber personnel to conduct all these different operations. So this has become as much a part of warfare as anything else, something to be considered. All right, do you have some quick questions? Because we're going to the next part of this thing.
Hey, Joe, Robert here. It doesn't look like we have any questions at the moment. I would again invite everybody, if you have questions, feel free to put them, text them into the chat there. But for now, Joe, feel free to push ahead.
All right, I will do so. Okay. So, any rate, in the 1990s, I was working with Tony Zalewski at Hexagon Interactive, and we got a contract to do a game on the Persian Gulf. And we actually got two contracts. One is for a game called, let me get back to that later, Crisis 21, and the other was for a game called Cyberwar 21. There's a lot of overlap, so I'll discuss them together. The idea was to do a game, a computer game on the conflict in the Persian Gulf, but would have the cyber war overlay to it. And one of my starting points was Colonel John Warden and systems warfare. He was an Air Force colonel, and he came up basically the plan for the Gulf War air campaign. And the idea was that an enemy is a series of overlapping circles with his leadership, then followed by various types of infrastructure, and then by the fielded military. Okay, the idea was that if you take out the inner circles, everything else collapses. So if you knock out the enemy's power grid, well, their industry goes out. If you knock out their command control, their military can't fight. So his whole idea was to use precision-guided weapons to knock out the Iraqi critical infrastructure and enforce their collapse on the ground. And this was the actual air war plan that was employed during the Operation Desert Storm back in 1991. Okay, so anyway, we did two games. One was for DARPA, and the other was for the Air Force Office of Scientific Research. This is the battle space screen. This is a standard war game screen. You have military units, and this shows Iraq, Kuwait, and northern Saudi Arabia, and a chunk of Iran. And so basically, you maneuver your standard units across the battle space. Pretty typical stuff. All right, this is the system screen. What the system screen does is show your infrastructure. And each of these markers on the map corresponds to a different type of infrastructure, which you can see on the far right. For example, you can see the you have power grids, and you have government. So this is a way to keep everything sorted out. All right, here's your order of battle. What we did is that we divided the different game functions into areas based on the standard joint staff system. So the J1 covers the order of battle, and you can see you have the Land Component Command, the Joint Air Component Command, the Joint Special Operations, and Joint Maritime Commands. And the various maneuver units you have for them are shown within those boxes at the top. And then the boxes in the center and the bottom show your various strategic assets, including things like electronic warfare, intelligence, special operators. And then the middle, rather the bottom row shows your critical infrastructure. So this is a way to keep all your forces sorted out. Okay, this is your information operations screen. Here we've targeted Kuwait City, and the orange circle shows the infrastructure that's within Kuwait City. And the yellow circled items on the left, those show you your various assets. For example, you have the cyber cadres, and internet cadres, and hyper cadres, all of which allow you to penetrate enemy systems and launch cyber attacks against these different types of infrastructure. You also have other things like satellites, special operations, and so forth, which you can also use. So this is a way to sort everything out and to give you an interface that allows you, immediately identify what you're working with. All right, and then you have a course of action generator. And the idea here is that each course of action represents a different, basically prepackaged strategy. So for example, you can call in UN weapons inspectors, or you can call in an organic insurgency. And the idea here is that you just don't go from turn to turn making up stuff as you go along. You actually have to have certain standard operating procedures. And then each of these courses of action will give you different bonuses for conducting operations. And if you'll notice, they're sorted out by information warfare, air and systems, battle space, and economic. And then the information on the left, lower left, shows you the outcomes of your operations. Okay, and this is the Chief of Staff screen. And this basically summarizes what happens during the turn. And you'll notice we've gained information superiority just about everywhere. So we're happy with that. Okay, so that's that game. All right, let's look at the different Let's look at the different generations of warfare. This is sorted out in different ways. This one is good as any. First generation warfare is essentially traditional gunpowder level warfare. Second generation sees more technology on the battlefield with more firepower. Third generation sees the breakthrough with mechanized warfare and deep operations. And fourth generation is insurgency, where things become much more asymmetrical. Okay, so when you have asymmetrical warfare, now suddenly you're attacking a stronger foe, maybe using propaganda, maybe using terrorism, maybe using civil disobedience. All right, well, that leads us to fifth generation warfare, which is the introduction of technology into the battlefield. Now, this has a critical implication because it takes asymmetrical operations much, much further. For one thing, while the first through third generation warfare usually were conducted by nation states, and the fourth within a nation state, even though it might be a non-state actor, fifth generation warfare now sees people operating transnationally. Okay, so people via the internet can now operate worldwide, and also you have guerrillas starting to become transnational too. You have groups like the Islamic State, which essentially cross borders and operate freely and take out their own new territories. The same thing with criminal cartels, warlords. So what's happening is an erosion of the older concept of war between nation states or war between imperial powers. Now it becomes war between different groups that can organize around networks. All right, and this goes across the full spectrum of operations. I'm sure you've all seen graphics like this, and there are all sorts of stuff that happens. Okay, so you have conventional operations. And you have little green men. This is a term used for Russian infiltrators who move ahead of Russian conventional forces and basically to seize objectives, but they don't wear any kind of identifying insignia. So the idea here is that they prepare the way for the conventional forces. You have non-governmental organizations, all right? And these have become a major power, major player in the world today. Often they will conduct operations worldwide, sometimes humanitarian, sometimes they become involved in things like mass demonstrations. For example, you had a youth movement organized via social media with support from major corporations and apparently various government agencies, which has been involved in the various color revolutions that we've seen in the Middle East and Eastern Europe over the last 20 years. So what's happening is that the whole line between conventional armed forces and civilian population has been broken down. Operations take place across the entire spectrum. Everybody's involved, and anybody could be involved simply by logging onto the internet. Okay, so what you're seeing here is a very big change in the nature of warfare. Global guerrillas. And the idea here again is that guerrillas operate transnationally. They don't necessarily, their goal isn't necessarily to overthrow a single government. Rather, it's to stake out territory, and even if they don't zones, then they've gotten what they want, which is a certain degree of independence. Okay, you also have private military companies becoming a player. Okay, so you have, these are additional boots on the ground, but they're also obviously you can bring in various specialists, including cyberwar people. Okay, and you have demographics. This is the Turkish-Greek border. You push people across the border, and suddenly you give the other side a real problem because now they're being overwhelmed with refugees, and they have to deal with that. And so this becomes a form of warfare. You have paramilitaries. This is the Ukrainian Azov battalion. Actually, it started off as a battalion and later on was upgraded to a regiment. And this was essentially a very effective militia, which the Ukrainian government used to fight the Russian paramilitaries in the Don Basin. Okay? And because they proved so effective, they effectively became a regular force. And again, it's worth looking at them because they also have a very strong political component. It's not just simply about fighting the other guy. It's also about gaining a certain degree of political power on the home front. And you also have globalized economic operations as industry and finance and communications become global. Again, it breaks down more national borders and things start coalescing into megacities. All right, and the idea here is that a megacity, these are going to have like 20 million or more people. They will be centrally run by computer systems. Also, they will be linked worldwide into a wider, essentially, confederation of megacities with common interests. At least that's one theory. So you have to look at the fact that the global landscape is changing. All right, open source operations. As I say, anybody can participate. And whether you're working for a major government agency or just a lone operator in your parents' basement, guess what? You can be involved. You can put up bulletin boards, you can do communications. There are people who do hacking. You can support people involved in a color revolution. You can support people on your own government by providing information. So suddenly everyone is involved. Okay, so the old days of an insurgency having to have a huge infrastructure, not necessarily the case anymore. What you need is a lot of people who are self-motivated and can work with you via networks. Okay, this is the Euromaidan protest in the Ukraine. Essentially, they launched a coup which changed the Ukrainian government and replaced the older pro-Russian president with a newer pro-European Union president. This is the Eurasian Youth Union. This is in Russia, and they also operate apparently in Central Asia. And basically, it's a counterbalance to globalized operations. And their idea is that they're going to form a consolidated power bloc with Russia, Central Asia, and their allies, let's say Syria and Iran, to counteract Western Atlantic, what I usually refer to as the Atlantic world, in other words, the Western world. And they're going to contest them for control of the streets, control of cyberspace. One aspect of this is the Russian government has banned many Western non-governmental organizations from operating within Russia because they see them as fronts for foreign operations. Okay. All right. This is a graphic that everybody is now producing. It shows their new high-tech soldier of the future. Everybody has their own version of it. This is the German one, individual defense system. And so basically you get your great big assault rifle and you get your computer, and you get your navigation devices, and you get all sorts of other stuff that, that you need to go into modern conflict with. And so it's all integrated together and it's all connected to centralized networks. So the soldiers of the future are going to become increasingly high tech, at least that's the theory. However, the critical thing is that it's not necessarily regular soldiers. Obviously, all this stuff, most of this stuff is available by going down to your local electronic supply store, and you can put together this stuff too. So this is going to spread and become more common. All right, so how do we get this into? In Central Africa, you have a country called Mali, and the Islamic State, actually a coalition of groups calling themselves the Islamic State in the Sahel down there, took over a sizable chunk of the country of Mali, including the ancient city of Timbuktu, which you can see in the lower left. And the French led a coalition of countries to kick them out. Now, the critical thing is that the French operated as part of a coalition, and most of the boots on the ground were from various African countries. And one of the reasons they could get so much support behind them is because, frankly, most of the people there didn't want to be ruled by the Islamic State, including most Muslims. So the first rule here was that you get local forces behind you, then you can operate. Because you have the local forces behind you, you've got your logistics, you've got local intelligence, you got local infrastructure. One thing the French did I thought was interesting is that they had local contractors provide them with bottled water, so it reduced the logistics load. And the United States did provide a few transport aircraft and some satellite intelligence. All right. And there are some French soldiers in the upper right. One of the things that's interesting is that the French Foreign Legion was there. They conducted a parachute drop to Timbuktu. This game appeared in Modern War magazine, Operation Sorel, Expeditionary Warfare in Central Africa. And that's Timbuktu, it's circled there. And you'll notice there are parts of other countries involved because the insurgency was transnational, so they all get involved too. Okay, these are the counters. Now you notice most of them are sort of NATO standard counters. However, the counters in the lower right are your various hyperwar markers. Okay, and these represent different things. The orange ones are the Islamic State ones, and the blue ones are the French coalition ones, and they involve things like, okay, ISR, intelligence, surveillance, and reconnaissance. You have Cyberwar CW, you have terrorism, you have terrorist spectacular, you have UAV strikes, and you have direct action. And each of these has a different functional distinction. You hold them off map, and then when you want to employ them, you slap them down on the map. So the ISR counter, that lets you see what the enemy has. Cyberwar lets you basically sabotage the other person's command control systems. Direct action and terrorist spectaculars, these allow you basically to really disrupt the other guy. And UAVs give you a couple of minor combat advantages. The point is, this is a way to quantify all this technological warfare into a format that wargamers understand, because wargamers understand cardboard counters. And let me also note here, you can also impose Sharia law if you want to, which gives the Islamic State advantages, but on the other hand, there's a human dimension, and so it causes a blowback as the locals don't want to be ruled by the Islamic State. So there's a political dimension to the game too. Okay, another game I did is called Putin Moves East. Now this is actually a scenario generator for various conflicts in the Far East. So it covers Mongolia to North Korea and South Korea too, and parts of Russia. And there are 6 different scenarios. One of them deals with a conflict over Mongolia, and a couple deal with Korea. Another deal with a highly unlikely war between China and Russia. This is pretty much a standard war game, but I worked all this into the order of battle. All right, this is the Russian order of battle. Certain units have a plus sign. These are hyperwar units. Basically what it is these are units that are networked and have high technology equipment. Okay? And what this means is that they can all operate together. Normally the way this game system works is that each unit moves and fights by itself, because each unit is basically a core-sized task force. However, the hyperwar units can all move and fight together. So what the game comes down to is that often large armies will lack the command control and the networking to actually coordinate, whereas a smaller but much more networked army can run rings around them. And again, if you look at what's going on, say, in the Persian Gulf, since 1991, this has been a situation. And it works both ways. I mean, in the in Operation Iraqi Freedom, back in 2003, the U.S. pretty much ran rings around the Iraqis, even though they're much larger. On the other hand, you see insurgents often running rings around conventional forces, which don't have the same level of command control. One other aspect to the game are your cyberwar and units, and that's the third and fourth row. And these represent everything from cyberwar cadres to non-governmental organizations to some special forces. And the idea here is that these provide you with various combat bonuses because you're employing cyberwar and other unconventional operations. Also, the unit on the fourth row that's circled is a 6th generation warfare unit. And basically the way that gives you all sorts of bonuses in combat, but the way you get it, you can't recruit it. The only way you can get it is through combat. And after a certain number of combats, there's a chance of it showing up. And so the idea here is that the troops on the ground are learning. And so that's where you're getting your new information, not because some central mobilization, but because some private up front came up with a better way to use a cell phone. And so there's your unit. All right. Back to Europe. This is Ukrainian Civil War. This has not yet been published, but you're getting a sneak preview anyway. All right. And this is based on the fighting that's been going on in the Ukraine since, well, almost a decade now. And you have 4 factions. You have the Ukrainian government, you have the Ukrainian nationalists, you have the Russians, who also include their various paramilitaries, and you have the European Union or NATO. Okay, provinces are divided up into 2 types. The green ones have a large Russian population. The blue ones are the ones with a large Ukrainian population. That affects combat because you have local support. Okay. The various lightning flashes actually represent energy production areas, and then you also have cities. Now, one of the critical aspects of the game is that you have various crises which occur, like coups. And the more these crises occur, your escalation goes up. Now, if you see at the bottom, there's a track there, it's circled in red, it goes from 1 to 7. Well, the more crises that are in play, the higher this thing goes. If it reaches 7, the game comes to an end. Full-scale warfare has broken out, and now you have a turn to maneuver for position. So when the real war gets started, the real big shooting war, you now have a superior position. So you got to actually think about what's going on throughout the course of the game, because you're not simply trying to capture this or that objective. You also have to maneuver the level of international tensions, again represented by the escalation index. Again, a mix of NATO standard counters and various hyperwar markers. The coup markers are used to record who controls various provinces with the coup. And one of the critical things is that as you start gaining control of provinces, the geography of the map changes because certain areas now become worth much, much more because they're worth more when it comes time to end game victory. So you have to think about that too. All right, so here are some sample markers. They have the numbers. The first number is its conventional support. The second number is the cyberwar support. And you can see there are various types there. For example, you have cyberwar gives you a 1-2. It's worth 1 factor in 1 combat shift for conventional war. And it's worth 2 combat shifts for cyberwar. Others, like Little Green Men, are worth more for conventional war. Some of them, like deplatforming people and 0 Day, are worth a lot when it comes to cyber war. You have precision-guided missile strikes, and those are worth 3 for combat. So that's pretty good. Some of the other markers bring in special events. For example, if you control an energy cartel, you get more recruits if you control energy objectives on the map. If you have insurgents, you can bring in extra paramilitaries. If you have sanctions, you can undermine the enemy's recruits. And so you've got a lot of stuff going on there, and you have to think about not just what's going on in the game map, but also what's going on with all the various cyber capabilities and other unconventional capabilities you have. Okay. All right, any questions?
Yeah, Joe, we got a couple here. So earlier when you were discussing sort of like the non-lethal tools of warfare, you mentioned refugees as a tool for war. And so we had somebody ask, can you clarify what you meant by refugees being used as a tool of war?
Well, in other words, the situation you have on the Turkish-Greek frontier, where they have people they claim to be refugees, and they push them across the border to undermine the border, and now suddenly you have your people on the other side of the border. And so this has caused a lot of disruption in Greece, including you have situations where the locals are getting into fights with the refugees, and then you have the police coming in and getting into fights with both sides. So it's a way to disrupt the other side.
Excellent, thank you. And then our next question, actually, I believe was in reference to your last slide. And that was just one of the counters, I believe, or the markers. It was, can you explain cyborgs in this context? So the cyborg marker there.
Yes, cyborgs, that's a term that's used by the Russians for some of their super soldiers, okay? So it's not an actual Terminator type of cyborg. It's actually for soldiers who are so, proficient at cybernetic warfare and conventional warfare that they're able to be very combat effective.
All right, and then one more question from this batch. Can you unpack what you, I guess, define as sixth-generation warfare?
Well, that's a term for the next generation of warfare beyond fifth-generation warfare. And basically, I was actually going to go to that a little later, but okay. What that means is that you have the soldiers themselves are being transformed by the combat operations. So they're coming up with entirely new ways of fighting that we may not be aware of could even exist right now. So for example, if you went back to World War I, you had the German Stoßtruppen who would conduct infiltration operations. And this did not come out of any central planning as much as lessons learned in the trenches and the creation of new type of soldiers from sort of the ground up. So it's speculative, and you could use the unit, in any way you want to. If something new comes down the pike next year, you could say, okay, sixth-generation warfare will give it this special capability. I always tell people, it's your game. One of the great advantages to board war games is that you can do whatever you want with the counters. You can add extra combat factors. You can rewrite the rules. So let's think about what's going to happen in the next decade. Okay.
Yep, definitely. Thank you. And I think that is all that we have for questions at the moment, so feel free to proceed.
Okay. All right. So let's deal with how we deal with network-based warfare. This slide shows various types of organizations. If you look at the second one, hierarchical institutions, that's what we're used to thinking of. It's like the Department of Defense. Okay, you have a Secretary of Defense. It goes down through chain of command. You have, with units at the bottom end of it, you have unified and specified commands. The same thing has been true of traditional insurgents. You would have a central leadership cadre with a wider front, composed of various insurgent organizations, and then beneath them, a wider underground of sympathizers. Well, now, if we go over to the right-hand organization chart, networks are organized differently. Instead of having a centralized leadership, you have many nodes which are connected by network lines. Okay, so it's very much more difficult to knock out because there's no real centralized leadership. Of course, the downside is because there's no centralized leadership, you end up with a situation where often everyone's going in their own direction. So there are advantages and disadvantages. Well, how do you show this spatially on a game map? Well, there's several ways. All right, first of all, let's go to the Battle of Algiers. How many people have seen this? Has everybody seen this movie? Well, if you haven't seen it, go out and see it. It's based on the French counterinsurgency in Algeria, which took place essentially from 1954 to 1962. And the central problem that the French face is that the underground organization is really well embedded. Okay, they set themselves up with a cell structure that's very hard to crack because each cell is even though it is under a central command, people only know their immediate cell leader. So what happens is that even if you knock out one cell, the whole organization remains. So the movie shows all the stuff the French had to do, including use some very unconventional methods to finally break their organization. But even then, in the end, it didn't work. Okay, and that's what a cell looked like back in those days. Notice nobody, even though it's a cell, nobody had a cell phone. All right. Well, today, in the cyber era, you have networked organizations. So you have Al-Qaeda and has all sorts of organizations supporting it. For example, it has banks and financial networks. It has allied groups. It has training camps. And again, though, this is not done with a centralized organization as much as it's done through networking, much more difficult to knock out. So how do you show that on the game map? Well, one of the advantages, oddly enough, that we have these days is that because everybody is so tied in to the internet, and here we have some insurgents, and they're sitting around looks like a laptop in the foreground doing some kind of cyber operation, or possibly playing a video game, is that because everyone is so tied into the global internet, the advantage now shifts to people who have the high ground dominance in electronic warfare and cyber war and all these other things, and information operations. So whereas in the past, people might have passed information by clandestine drops or by messengers, now because everybody's on their cell phone, all this information can be tracked and data accumulated. So in a way, what's happened, ironically enough, is that even though all these technologies enable global level guerrillas, it also provides a huge vulnerability. By the way, I assume everybody on the East Coast knows what that building is. Okay. So getting data now becomes critical. I'll give you a second to read the cartoon. Okay. So getting the right data becomes critical. And this is important because if you're fed the wrong data or if you're politicizing your data, then what happens is that you're going to undermine your operations down the line. All right, for example, 2002, Operation Millennium Challenge. This is a year before Operation Iraqi Freedom, our move into Iraq in 2003. Okay, the idea behind Millennium Challenge was to do a war game which would have both computer and field training exercise components. In fact, it cost $250 million, supposedly. And it would show the US moving into an unnamed Persian Gulf country, the idea being to take down a dictator who possibly had weapons of mass destruction. Okay. Well, the blue team, in other words, the US coalition team, was played by military people. The red team was commanded by General Van Riper. He was a retired Marine Corps general who was known for unconventional tactics. Well, what did he do? He understood how Americans fought. So instead of having cybernetic networks and electronic communications, he based the communications between his various forces, both simulated and in the field, on messengers and giving guys on motorcycles packets of information. And instead of trying to attack American forces head on, instead he used things like suicide boats to attack fleet units and also a barrage of cruise missiles. Well, the result was that on the first day of the exercise, he managed to sink one US aircraft carrier, simulated aircraft carrier, plus about, I think, 17 other ships and damaged many more. Well, at this point, the exercise was called off and they basically handed the red team a script and said, look, this is how the exercise is supposed to go, okay? And so then they ran it again. This time, it seemed that the American forces had won, but even then, it did not prevent what would become an insurgency from occurring within the framework of the game. And of course, this is what happened in 2003. In fact, this is not the only time something like this has happened. If you go back to the early 1960s, before the US went into Vietnam, the Pentagon ran a couple of games they called the Sigma War Games, simulating what would happen if we went into Vietnam. And both of them pretty much showed what actually happened, that putting more troops into Vietnam would not solve anything. Bombing the North would only harden the resolve. And the interesting thing is that even though these results came out and pretty much proved accurate, they were pretty much buried. But it's worth looking up, Sigma Wargaming. By the way, I always like this kind of thing because it shows wargamers are right. Okay. So here we have an anatomy of the internet, okay? And you take a quick look at that. You have the World Wide Web. In other words, a series of embedded surfaces here. So you have the World Wide Web, and then you have the surface web, and underneath you have the deep web, and then the dark web, and the deep dark net, however you want to think of it. Okay, so the question is, how do you show this in a game? Okay, well, I worked with Dr. Roger Mason on a game called Cyberstrike, and there's Dr. Mason, and we gave this demonstration at West Point a couple of years ago. And this is the prototype playtest version of it. The actual production version will be much higher quality. But if you'll notice, the part on the left is the open web, and the part on the right is the deep web. And the way it works is that anybody can move on the open web, but to get into the deep web, you have to find certain access points, okay? So to get those access points then means a struggle within the realm of cyberspace. And then once you get into the deep web, you now can gain access to all the really good programs. And aside from that, you're in a position in the deep web to strike anywhere on the open web, but not vice versa. So again, this is a way to visualize the terrain of cyberspace. 1996, I did a game called Cybernauts. This again is a magazine game. And the assumption here is that you had a worldwide group of agents who are trying to gain access to a global level internet. And the way it worked is you had two different echelons. The part on the left is the real world map, and those reddish symbols within the black symbols, they represent various types of cities, and each type of city has different stuff available. So you go to these cities, and then you have sort of an adventure, and then you can get various programs which allow you to penetrate into the internet, okay? And we found that players liked that real world part because it was sort of fun to adventure around. Okay, on the right-hand side, you see the depiction of the internet as we saw it. And the bottom part is basically the open web. That's what we call the open web today. You have access points represented by the green and red symbols, and they correspond to different cities on the map. So if you come in through, for example, L5, which is actually a planned space station, you end up in the center of the map. Other cities bring you around the periphery of the map. And once you penetrate into the open web, you then are looking for nexuses or doorways into the more deeper parts, which are represented by Core A, Core B, and Core C. And notice you can get into them also by going to some classified objectives like NORAD and Cosmograd, but those are much more difficult to get into. All right, these are the unit counters. The pieces in the top row represent your agents. The guys on the bottom left with the pistols, those are your security forces. And so the security guys are trying to hunt down the agents before they cause too much damage. The various things that say virus, logic bomb, probes, those represent different types of programs you can use to penetrate into the net. Okay, and it's based on the kind of classifications you had in the 1990s with logic bombs and backdoors and other stuff that we still all remember. The ghost is actually your avatar for moving around within the internet. So you place the ghost marker on the internet. And the black counters on the lower right are actually various weapons and technologies you use in the real world. So for example, you have an encryption program that allows you to break into things a lot easier. And you have guns and other stuff out of the cyberpunk world. So a meat puppet allows you to bring back a dead agent from the clone banks and the other science fiction stuff. All right, what you're going after are the files. The files represent different things. Some of them represent finance, some of them represent intelligence, some of them represent control. And so the idea here is that you're searching for these things. And the idea is this is a way to visualize the various kinds of objectives you're going for, okay? And again, it goes back to William Gibson and the whole cyberpunk genre, where you're visualizing the interior of the internet as a series of 3D objects. The nexuses represent various doorways within the internet. Now, this is a typical setup. You'll see here the red circled pieces represent system defenses. ICE is intruder countermeasure electronics. These block the movement of intruders. Then you have a tracer, which is kind of a reconnaissance program. And you have a virtual reality missile, which allows you to knock out the ghost. The ghost has come in through Silicon Angeles, and he's fired a probe. the idea he's going to do his own reconnaissance to figure out what's going on. Okay. All right, any questions?
Yeah, Joe, we got one right now. And that is, so for the purposes of, so for most purposes, do you see cyber effects or effects of cyber warfare as enhancements to standard aspects of a combat environment, such as land, air, sea, a standard domain, if you will? Or are there any aspects where you think cyber has potentially radical different types of effects that are independent of traditional domains of warfare?
Well, at one level, they are a super command control information warfare system. Okay, so in other words, you could have, I mean, don't forget, we had big wars before the internet. Look at World War II, as an example, or any other war. So you could do all this stuff without the internet. But where I do see the big change comes about that you can now do networks with people distributed worldwide. And in the past, that was very difficult. Today, you can actually have operations that are worldwide. We don't have to have people who are physically together. Also, and I'll get into this a little later, I think there are some major changes in psychology caused by the immersion into virtual worlds and into social media. Okay, so yes, there are going to be some radical changes, and I'll talk about that a bit later, but that's a good point. Okay. All right, so let's go back to the exciting days of 1955. This is the Los Angeles skyline. It's being lit up not by the sun, but by the reflected glow of a nuclear test out in the Nevada desert. Because back in those good old days, they would hold open air atomic tests, and tourists could go out there and watch these things and take pictures. And they'd actually hold rooftop parties in Las Vegas where you can watch mushroom clouds going up. And those are pretty interesting days, okay? Well, this brings up an interesting point. Since we're all dependent on all these technologies, and all these technologies are linked by electronic means, what happens when you have electronic electromagnetic pulse? Well, what happens when all these things go crashing down and suddenly your systems aren't working? What happens if this is caused not necessarily by a man-made weapon, but something like a solar flare? Okay, what if there's some virus that gets loose that brings everything down? Where exactly are we? For example, supposing we go to war with the country, okay? The day after the war starts, your computer goes down. So you pick up your cell phone, you call your tech support center. And your tech support center says, well, hey, you know, our country is opposed to your country. So you're not getting any tech support now. What do you do about it? You know, when you distribute things worldwide like this, suddenly you're losing control. Suddenly you're placing a lot of your technology in the hands of other people who may not necessarily be friendly. Okay, so here are the happy workers and peasants of Cubicle Farm number 47, and they're working hard to support you every day. Okay. Jean Baudrillard, he wrote on simulacra and simulation, or hyperreality. The idea was that people would become so immersed in virtual worlds, they would lose contact with reality, and they would think that the virtual reality was the real reality and respond to that and not to what's actually going on. Okay, and earlier I mentioned the Matrix. The original Matrix movie drew a lot from Jean Baudrillard. The idea being that people were now living lives that were not necessarily authentic, but instead lives that were simulated. And the question was, how is that going to play out? To give you one example, if you've played Halo, well, there's a multiplayer version of it, and they recently met some milestone where they knocked off something like 1 billion the hostile aliens. And everybody thought this was a great thing. But of course, they didn't really do anything in the real world. But on the other hand, it was a mutually shared experience. And who knows, for a lot of people, it does have meaning. Okay, so these are all impacting on, I think, the psychology of people, where it becomes increasingly difficult for people to relate to each other in the real world. For example, this is from Star Trek: The Next Generation. This episode was called The Game. And the idea is that everybody is on the Starship Enterprise is now wearing this headset, which allows them to play this essentially Super Pong kind of game 24 hours a day. And the way it works is that it gives you an endorphin rush, so that every time you fulfill a condition there, you get high off of the game. And it was meant, I suppose, a metaphor for the way people can be totally immersed into virtual worlds. But would that happen? Would people walk around with headsets? Well, I mean, how many times have you been to a restaurant or something? Well, not these COVID days, but have you been to a restaurant and everybody is simply poking away at their electronic devices? Are we losing the human dimension here? Are people becoming totally immersed in the virtual world? Okay, can we not? Are we losing our ability to deal with each other as humans? And this has critical implications because in the end, it just may be some guy with a 50-year-old rifle who kicks in the door of your basement and takes out that computer hacker who's going to be the ultimate warrior there. So it's something we've got to look at. This movie came out in 2009. Bruce Willis, Surrogates. And the premise here is that people download their consciousness into robots, which are like idealized versions of themselves, and they live their lives out in hospital beds, but they don't care because they're living vicariously. And the movie is a very disturbing movie. It's almost like a precursor to The Matrix, and it's worth checking out to consider how far all of this stuff is going to go. All right. Earlier I mentioned the German Stoßtruppen. Well, Ernst Junger wrote Storm of Steel about his experiences as a World War I infantry leader in the German army, and this became something of a military classic. His whole point was that the modern soldier was up against not just enemy soldiers, but also the whole industrial system. The Storm of Steel referring to the incoming artillery, machine gun bullets, and everything else. And that to overcome it, you had to have a change in your consciousness. That the soldier of the future would have to have actually a superior will to fight, and that consequently, this is going to cause major changes in the nature of warfare. And you can sort of see that today. Again, it gets back to the whole idea of sixth generation warfare, that if all these technological changes are occurring, it may make people more passive, it may make people at some higher state of effectiveness. So it's yet to be played out, and that's one of the reasons we do wargaming, to explore different avenues. All right, and this is one of the ways I did this. This is called Phobos Rising. It's a science fiction solitaire game. The premise is that you have rebels on Mars. Mars has been colonized by humans. And it's a solitaire game where you take command of the rebel forces. And this is a map of Mars, so to speak. And it's overlaid on actual geographical features. And so what you have are your various teams of soldiers, and they go around the map, and they have a combat factor, and they have a movement factor, but the eyeball means the character can do runs on the future version of the internet, which I call the net, and they have other special capabilities. The cross tools mean they can actually do repair, so if they're damaged, they can bring themselves back. But at any rate, the way it works is that you have a network track. Okay, that's the upper part of the map there, the yellow circle. Basically, you have a piece there that shows how far you've penetrated into it. Well, the higher you penetrated into it, the more you gain bonuses. You gain information on the enemy, you gain combat bonuses. The downside is the more you penetrate, the more the enemy understands where you are, and so the stronger will be the reaction. So it's a very fine, balanced game there. But the idea here is that by performing various missions, you're upgrading your forces. This is leader challenge. So basically the way this card works is that if you pass the challenge, you get enhancements to your cadres. And this means that your force is constantly changing throughout the game as you develop new capabilities. Okay. One other aspect of the game is that there are 4 different missions. And the thing is that each scenario is a mission, but you don't know what the mission objective is at the start. The only way you can get the mission objective is you have to do a net run. And that tells you then what your actual mission is. So essentially you're being dumped into a situation where you have to figure out what the objective is. Okay, so much as like today, you can look at many situations where you're operating in an environment of limited strategic intelligence, where you don't quite know who your enemies are, and you have to figure this out in the course of the game. So it's not a cut and dried thing. It's up to you as the player to determine all these things. So there's more to the game than just moving and shooting. All right, any more questions?
Yep, so Joe, one we have is, what is the future role of the adjudicator in such a complex multi-domain dynamic war game like those you've described?
Well, normally I work with two-player games or multiplayer games. But actually, yes, one of the things you can do is the limited intelligence aspect, where you have the actual real situation showing the actual position of everything in the, for example, the in the network. And you only, as the player, you're only allowed to see what parts of the information that you can actually perceive. Okay. Another thing is to bring in whatever new technologies that may be available. So the adjudicator may have a deck of cards representing whatever technology you think that might be developed, and you can determine, well, you've done a certain thing, so you get the super virtual reality command control system, or you've done something else, and now you get another card representing access to financial sources that you didn't even know existed.
Excellent, thank you. So with that, feel free to proceed.
Okay, so we're kind of bringing this to a conclusion now. All right, so Frank Herbert, in his Dune novels, one of the things he postulated was a reaction against thinking machines. He wrote back in the early 1960s originally, so I imagine he's referring to computers. But in his future, there are no robots, there are no computers. Instead, people must develop their own minds. Okay, this is from the 1984 version of Dune by David Lynch, by the way. And by the way, that's David Lynch, the guy with the bad haircut. And there are a lot of negative sides to all this, because if people become so dependent upon the internet, it's a way to become controlled. It's a way to be manipulated by propaganda. It's a way to have all, if all your finances are out there in cyberspace somewhere, it's too easy to lose all this stuff. So you have to think about the other aspect of it. This is Calvin and Muad'Dib. This is somebody took old Calvin and Hobbes cartoons and inserted quotes from Frank Herbert's Dune novels. And it's really funny, because they actually work better in a cartoon format than they do on the printed page. So here Calvin is saying, once men turned their thinking over to machines and the hope that would set them free, and then his bicycle is thrown over by his cat, his tiger, and the conclusion is that only permitted other men with machines to enslave them. So that gets back to the human dimension. I think this has to remain central. And that's vital for wargaming, because ultimately it's between players. And at that point, we'll take it to the general staff and ask if there are any more questions.
All right, so again, to the audience here, if you have any final questions for Joe, just feel free to put them into the chat here. And Joe, if you don't mind, we'll give folks here another minute or two, see if anything pops up.
Yeah.
All right, Joe, here's a question. So what development in warfare of the past 40 years surprised you the most?
Well, I think the low number of casualties that American forces have been taken. When Operation Desert Storm began back in 1991, I assumed that because the Iraqis had so many tanks, artillery pieces, that we'd be taking a lot more casualties, even just by accident. And I was, if you go back to Vietnam, even we'd often take 500 dead in a week. We didn't take 500 dead in the whole first Gulf War. So I think it's this very low level of casualties. But at the same time, there's a flip side, because we may be becoming casualty adverse. If we went back to our intervention in Somalia back in 92 and 93, we lost essentially 8 dead Rangers, and suddenly that was enough to close down the whole operation. So it just may be we're getting to this point where we don't want to take casualties, and that could be a very bad thing, because let's face it, if you're not willing to fight and die for your cause, you're not going to win any war, no matter what technology you have. So I think it's something that needs to be examined, and I don't see very many people examining it.
So next, how do we determine potential cyber-related actions in advance? Aren't those potentially outdated quickly due to the technological pace of change?
Yes, that's true. just have to keep on top of it with your own intelligence operations. But I mean, the reality is that it's not just simply anticipating the actual individual actions. It's setting up a system where you can manage these crises in an intelligent manner. Now, Dr. Roger Mason, with whom I work, has developed some exercises along those lines, and a lot of it is having the capacity to sit down and say, okay, this is how we're going to deal with this crisis. We're not going to panic. We're not just trying to put out the fire. We're going to look at the bigger picture, and we're going to manage the entire thing. And that requires actually a lot of preparation ahead of time, including doing exercises and wargaming.
So learning algorithms, or machine learning, seem to be the next wave of computing. How will you incorporate this into near future models?
Well, actually, yes. That's one of the reasons why I use cards. Now, again, bear in mind, we're talking board games here, but you have several types of cards, okay, several classes. And certain types of cards would only be shuffled into the deck only after you've done certain actions on the game map board or invested in certain technologies. So the nature of the deck changes. And also by having faster action reaction times. So.
In your opinion, what is the best way you have seen non-kinetic effects like cyber integrated into a wargame?
Well, in projects I've worked on, we did a cascading effects generator for the Crisis 21 game. That was the computer game done for DARPA. And the way it worked was that every time you did anything, it affected everything else. So it would affect morale, it would affect ability to produce certain types of equipment. And the critical thing was, of course, you couldn't do this in a board game because it would require, you know, a couple thousand die rolls a turn, but obviously the computer could handle it very quickly. But that's the thing about computers, that the big advantage, it does all the routine calculations, so it frees the players up to do the game, whereas board gaming, you got to do the calculations yourself. On the other hand, with board gaming, it's all transparent, so you can change things, and you can see how the processes work. So there are advantages to both.
Have you thought about creating a game that depicts maneuver, defenses, and fires in cyberspace, and where cyber runs at a different time scale than in the physical domains?
Yeah, to some degree, the Cybernaut game is about that. It does actually use a collapsing time scale, because when you do make a run into the internet there, you actually, play is suspended and until the net run's completed. So it's assumed action is taking place within an hour of real time as opposed to action otherwise, which was anywhere from a couple of days to a month. So yeah, use a collapsing time scales.
What is the next wargaming hurdle with regard to introducing cyber, electronic warfare, military decision-making, et cetera, into traditional or conventional war games? So how do we better show these non-kinetic effects on a battle space or on a war game?
Well, if you're talking board gaming, is to give units an off-map display, which shows not only their capabilities, but also how they've been affected by various kinds of cyber attacks. So you could, I was thinking something in terms of, you show the mental state of the troops, you know, are they actually engaged, are they actually focusing their attention on the operation, or are they been distracted by all sorts of virtual reality, you know, offensives directed against them.
So in designing cyber war games, how do you think about and then model red lines in the context of cyber warfare?
Could you give me a better definition of red line?
So I believe, and whoever asked this question, feel free to clarify this in the chat if I'm framing this in the wrong way. But basically, I think escalation is my understanding of sort of cyber escalation, and crossing those red lines, increasing the effects or the magnitude of cyber attacks.
Oh, okay, right. Well, the way we do things like that is basically you have an index. Okay, so it can go anywhere from like in the Ukraine game, 1 to 7, you go anywhere. Sometimes I like to use it 1 to 100 because that way you can more finely grade it. But the idea is that as you reach certain stages and you cross certain lines, different things happen. So for example, if the crisis, let's say you're doing it on a scale of 1 to 100. Okay, so let's say when you reach the point where you're at crisis level 50, suddenly you can do other things, like, for example, launch malicious attacks. Whereas when it's underneath that, you can't because of the political constraints. Now, obviously, you can have also ways to modify this. But usually you can quantify things with an index. That's a very standard thing in wargaming. And also, you could have unintended effects. So, for example, if you're above a certain level, well, you pick a card from a different deck, and that has a bigger ramification, so you can actually see how far you can push it. So once you get up to, say, level 75, you have like massive cyber retaliation. That card is stuck in the deck, so you're constantly pushing the limit there.
And what is your go-to source for types of cyber attacks and tactics?
Well, actually, the internet, actually. There's all sorts of information out there. But I also have an extensive library of books that have been written over the decades. There used to be this magazine called Mondo. I think that's what it was called. And it dealt with a lot of the cutting edge of cyber warfare, cybernetics. I stopped publication a while back, but they had a lot of interesting stuff on where virtual reality and other things were going. So yeah, there are a lot of sources out there.
Do you believe war games or other simulations could be weaponized to give lower tech asynchronous opponents, especially terrorist organizations, a capacity to use virtual attempts to make their efforts more sophisticated and probable to succeed?
Well, anybody could use a war game. It's like a book, okay? I mean, the critical thing is that our side makes use of war games, so we stay ahead of the game. There's no way you can really keep this information restricted. I mean, there's so many people involved in wargaming, and there's so many, it's so easy to produce war games now through desktop publishing that there's never any way you're going to get it under kind of a centralized control and say only certain things can be done. I mean, if somebody else, if hostile forces are using them, then we should be using them too, and then use them better.
So if there's a dependency on cyber for C4ISR, and it is vulnerable to attack or disruption, but with relatively long lead time for exploitation and disruption, do you think that it will encourage faster kinetic activity to beat the attempts of cyber activity?
Yes, because you're getting faster command and control loops. But I'd also say that everybody should have a plan B in case everything goes down. So you should be prepared to have a squad of guys on motorcycles with messenger pouches to give out the information just in case you need it. I mean, the thing is, if you went back to Colonel John Boyd, who popularized the term the OODA loop, in other words, the side that has the faster action reaction time will win. It's true, but there's another side to that the side that can outweigh the other side will have an advantage too. This is a point, I believe, during one of the Israeli interventions into Lebanon, where the Israelis might have had the fast tactical action reaction time, but the people they were fighting were in a situation where they were willing to set out the intervention and felt as long as they can destroy a couple of Israeli tanks, they had actually gained something of a victory because they can now claim this is a political victory. So you got to be prepared to play the long game here.
Do you foresee that we have, for the most part, seen the end of successive regional conflicts and are moving towards continuing global competition? This question actually references your chart showing the history, change of networks, references that as sort of capturing this concept.
No, I think they're going to be more regional conflicts because, as things, I think, as you have more globalization, you have traditional nation-state governments falling apart, and so things tend to break up to where regional forces, whether they're warlords or paramilitaries or criminal cartels, are more willing to stake out their own territory. So you're going to possibly see this kind of bizarre two-tier system with globalized forces at the top, and then down in the trenches you have various local forces staking out their own territory. There's some interesting studies on African warlords. Their whole point is they're not so much fighting to take over a country. They just want to stake out their own territory where they run things. And that territory may change. They may cross a border and suddenly they move their stakes somewhere else and it's just as effective. So expect more breakdown.
And so the same person asked kind of a second part as well. Do you foresee additional elements, whether lethal or non-lethal, creating other axes to this concept, to this global competition? So like, for instance, they give the example of decision-making speed, likely tied to machine learning, as we've talked about already.
Yes, I think there are any number of ways this thing is going. I think, though, that I wouldn't get too obsessed with AI because, ultimately it comes back to that human dimension. And it just may be that people find there may be some entirely new technology that comes up that renders the whole internet totally obsolete. So that may be out there somewhere. If I knew what it was, I'd cash in on it right now, but I don't. I'm not sure if I'm answering the question there, though.
No, I think that's good from the way it was framed.
Yeah.
In your opinion, where will AI have the biggest impact, looking at tactics, operations, or strategy?
Well, my honest response is don't get too obsessed with artificial intelligence because ultimately that does come down to human decision making. The biggest thing I see in wargaming is to have an artificial intelligence that will replicate, an intelligent game response. Because right now, it usually, no matter how you do it, and I've worked on some games with artificial intelligence, the player always seems to have the advantage. So there'd have to be a much more realistic human style artificial intelligence. And maybe we're just not there yet.
So considering cyber warfare between your peers, or by the timeliness of decision-making is critical, what's your recommendation for evaluating the C2 necessary to be effective in this context?
Offhand, I can't say. I'd say that you need to have I think you need a combination of centralized and distributed command control. One of the things that's been found in third and fourth generation warfare is that you have to have central leadership which provides overall mission orders, but you have your local commanders given plenty of flexibility to carry it out. And the problem is that I think that because you have things so overly centralized, because of the current command control systems, you may be cutting out those mid-level echelons, whether it's battalion or division. And so what's happening is that you're losing the ability of the local commander to actually act on operations, act on information, and then conduct combat operations. I think a lot of this stuff is yet to be tested out because the truth is we haven't seen the United States up against somebody who's really a near peer in a while. Certainly not in the last 20 years. We're dealing either with asymmetrical foes like guerrillas out in Afghanistan, or in the case of Iraq in 2003, an enemy that pretty much had fallen apart owing to sanctions, and yes, go into our information operations in cyber war that were during the run-up to the campaign. So the only, they tell a lot of people, the only real test is combat, and you want to make sure you're prepared for that. So do more wargaming.
You highlighted cascading effects calculus. Are there any models, data sources, or logic you can point to that account for cascading third or fourth order cyber effects? So as this person asking the question phrases it, cyber dynamics, essentially.
Yeah, the Crisis 21 game we did for Air Force Office's scientific research, we had a very good model for that, I think. It certainly handled all sorts of factors in a organized fashion and actually returned results that were useful. I'd also check the works of Colonel John Warden because he actually pretty much popularized the concept, and he's I think he's still around today. So.
When you design cyber warfare games, do you conduct deep research in the cyber warfare philosophies of the Russians and Chinese?
I'm sorry, can you say that again?
Yeah, so when you design cyber warfare games, do you conduct deep research in the cyber warfare philosophies of the Russians and Chinese? The way that they view cyber warfare?
Yeah, yes, I look at the mindset behind them. That's something I've always tried to get into games is the mentality of the players. In other words, the people you're simulating. And often this is done by things like using cards and giving each player a specific set of cards that are relevant to different types of cultures. So you're not just playing against an American who's commanding Russian forces. You're dealing with a Russian mindset. And this gets back to, I mentioned the Eurasian Union earlier, but I've done a lot of research on the philosophy behind that and the whole mindset that the Russians have towards how they're seeing the global level conflict, which means essentially setting up a geopolitical bloc in Eurasia to oppose what is usually termed in geopolitics, the Atlantic oceanic power. So one way to do that is, like I said, again, is to use cards. Why I like using cards, because you can then the cards, by limiting cards for each player to certain types of strategies, you therefore move them into the mold of the original mindset, but you don't actually force it. Oh, by the way, Dr. Roger Mason just handed me this. This is called Winning in Fast Time by Colonel John Warden and Leland Russell. So you might want to check that out.
All right, so Joe, I think this could be our last question, but it's a fun one here. So I think it's apparent to everybody here that you obviously have a deep love for science fiction. And so we had somebody ask, who is the sci-fi author to watch for next, in your opinion?
Actually, I can't think of anybody offhand. It's not much of an answer. I like William Gibson, especially even though he's kind of he's from the 80s and 90s, because he does have a good sense for the way the whole future of cybernetically oriented societies is moving. So, but I can't say anybody that I can think of in the future. I'm still working my way through reading Dune for about the 20th time. So, okay.
So beyond that, we actually do have some more substantive questions here. So are you aware of any games that explore the economics of cyber war? So like the cyber economic burden or economic burden related to like cybersecurity, whether in the civilian context or military context.
Roger, do you want to answer that?
I'm not familiar with any.
Okay.
Yeah.
I'm not really familiar with any, so.
All right, so at the moment, that appears to exhaust our questions here for the evening. I want to thank the audience for being very engaged this evening, asking a ton of questions, and I think stimulating a lot of great discussion. But most importantly, I want to thank you, Joe, for your presentation this evening, spending your evening with us, and sharing some of your knowledge with us and the audience at large here. For those in attendance, as I stated at the beginning of the presentation, our next event is going to be on December 8th. You